So this is officially the largest room I've ever spoken to, so I'm a little bit nervous. Can you hear me in the back? We're good? Okay. So taking back the command line with Go, my name is Mike Gehard. I work for Pivotal Labs out of our Boulder office. Woohoo, Boulder. That's why I'm walking around without my shoes on. So we have some goals here today. My first goal is to kind of explain to you my understanding of where the command line world sits these days. Explain to you an incident in the Cloud Foundry world that caused us to rethink usage of a dynamic language to be named later in our CLI tool. Give you a couple of examples of CLIs that I've personally written in Go. And the last one is to get to, oops, wrong way. To get to 1,000 followers before I walk out of here. So I need 14 of you to follow me. It's small wins. Okay, so command line tools. How many people use command line tools? All your hands should go up. If they're not, you're probably a Windows user. How many people write command line tools? So a lot, quite a bit of you are writing command line tools. How many of you like to write C? All right, so we have these people down here in the corner, which is good. I'm glad you all like to write C. That's why we're all here. Even Derek doesn't like to write C. How many people like to write C++? Again, this folks down here in the corner that I'm glad write C++. My knowledge of C++ is circa 1994 was the last time I wrote them. So it's not so great. So why? Why don't we write these languages? Because they're kind of hard. We've talked about this. This is why Go was invented. Most of us don't know. How many of you that write command line tools know C and C++? Okay, so not too bad. How many choose not to write C and C++? Yeah, okay, about the same. I'm glad to see Rob does it too. It's like, oh, I choose not to. So what happened? Back in the day, there was a little small subset of people that were writing tools for the rest of us. We were consumers of command line tools. We have now become producers and consumers of command line tools. So the hands that went up was quite a bit. I couldn't count from here. So we're writing them for ourselves. We're writing them for others. We're getting stuff done. The community's become much bigger. So we don't want C. We don't want C++. So where do we end up? We end up in Java. So that's kind of the beginning. People start writing command line tools in Java. Then me and all the cool kids, we decide this language is awesome, which I still love writing Ruby. Written a ton of command line tools in Go. There's like 15,000 command line libraries in Ruby, just like everything else. All the hipsters are writing JavaScript these days. What do these all have in common? What is the one thing? Well, probably more than one thing. What's the one similarity between all of them? They're dynamic. Well, Java's not dynamic. Java's statically typed. They all suck. Other than that, thank you, Andrew. What? There's a runtime dependency. Yes, winner. I have a drink ticket in my back pocket for you. They all have runtime dependencies. And how many people like runtime dependencies? That's what I thought. So with Java, you've got the JVM. Was that someone was saying this morning? It's like the biggest mastery of computer science. Like there's been so much work that's gone into the JVM. I think that might have been Derek. But it's slow. So like when I want command line tools, I want this stuff done quickly. I don't want to sit around and wait for the JVM to boot up. So then, we have the language that I've come to love, Ruby. Anybody try to install a Ruby environment if you're not a Ruby developer? Yeah, that's a huge pain in the butt. Where's Wayne? Wayne, there's Wayne. Wayne wrote a library called RVM. This is the sole reason that library exists, is because, yes, thank you, Wayne. So before Mavericks, we were running like 186 out of the box on OS 10. We have finally gotten a current version of Ruby. Maybe try to download Ruby gems without an internet connection? Yeah, almost impossible. Concurrency, not super important for command line tools, but if you want to do some hard stuff, kind of hard to do in Ruby. especially if you're using MRI. Not exactly the fastest library out there. Again, command line tool is not a huge problem, but could become a problem at some point. So now we get to the big problem. So Ruby has caused us some pain on Cloud Foundry. We went into a large government organization to try to push Cloud Foundry. They gave us no indication of what we were going to be, like the environment we were going to be working in. We walked in with our command line tool, and they told us we had no internet connection. We're like, oh boy. They then told us we were going to be running on a Windows machine. Anybody tried to run Ruby on a Windows machine lately? Yeah. So what happened? That was not good. They ended up going back to the office and using Warbler to package up a JRuby package that they could run. So now we're running Ruby on the JVM. We're now like touched 2 of them. I was waiting for like a node thing to come in. That was it turned into a train wreck. It was hugely embarrassing for us. We're like, okay, sweet, we've got some work to do. Let's not do this again. We've all heard JavaScript. Not my favorite language for larger things other than like that much code in the browser. I'm not a big fan of JavaScript. So these are all hard too. I have dependencies. I've got all of this mess. I've got Ruby, which is a pain. I've got JavaScript, which requires Node. I've got Java, which has got slow startup times. So our goal with the Cloud Foundry rewrite was to go to no runtime dependencies and an easy-to-write, more mainstream language. Am I guess what language we chose? Yeah, that's why I'm here. If we had picked something else, C++, that would be a different conference. So it only took me 20 slides to get to that picture. So yeah, we picked Go. So Rob Mee, who is our now director of cloud technology, I think is his title, came to me and says, I want you to learn Go. I was like, okay, all right, that's great, Rob. So I started picking up some Go. We started writing some Go. And one of my coworkers came up with this quote. You guys can use this on marketing material if you want. It's native code without all the native issues. So I get to compile down to native binaries with a language that's actually kind of fun to work with, actually really fun to work with, has a great mascot. I don't have this runtime dependency. Now you're saying, that's great. You've eliminated a runtime dependency. What's the problem I have now? I have to compile for multiple operating systems, which thank goodness you built that. That was so awesome. Like compiling down to Windows on my OS 10 machine or on a CI box in the cloud is awesome. There's some edge cases, though, like if you compile on OS 10 and a Windows thing doesn't exist, you don't get it till runtime, but we can deal with that. There's going to be a talk tomorrow. I think somebody's giving a talk on how to cross-compile binaries. I'm not going to cover that right now. So this is good. I was very happy about this. So we went to Go. I started learning Go. I haven't done Java since like 97, I think. So some general themes that I came up with. The first one being embrace the interface. So coming from a Ruby background, a dynamic language background, I was not used to this. This is something we don't do in the Ruby community because we don't have the opportunity to do it. We create interfaces we do with documentation and things like that. So I learned to depend on abstractions, not concretions. It makes testing a lot easier because now I can inject my dependencies and I can write these test dependencies, which I'm not used to in Ruby. I'm used to just meta-programming the crap out of everything. And it's just not natural. The other thing that was really hard for me was checking my object-oriented brain at the door. So I started writing object-oriented Go. It was not easy. You're like, oh, it kind of works, and you're like, I've got these structs, and I've got functions, and I'm attaching to the structs, and then you start to feel this resistance. So I'm going to incent you as you start to write Go, start with functions and start with structs, and then start to add objects, quote-unquote objects, as you need them. These are not the first things you go to. This is just kind of what I found. So the first thing I did is I rewrote a tool. Somebody played with Exorcism, exorcism.io. It's a great website if you're learning to program in different languages. It started out as solely Ruby. So you were given a Ruby test suite. You were asked to write a very simple class to make the tests pass. That was great. Ruby command line tool. All of us had RVM installed. It was like the world was good. Katrina Owen, the person who started this, says, hey, I want to add some different languages. And now we've got like Erlang folks and Elixir folks saying, like, how the heck do I get a Ruby environment set up so I can simply interact with the website? we have a problem. So I rewrote this tool in Go in like a weekend, I think. It's not very big. I can show you the code. We'll actually look at some of the code. So the first thing I'm like, I don't want to write a CLI tool. Like, I've done that before. I'm also not going to talk about library dependencies. Pick your horse. Like, the community's working on that. Just figure it out. But we did use this library. This CLI library, I don't know if I forget the gentleman's name if he's in the room. This is awesome. Yeah, there he is. Thank you for this. It's a great library. We were, I think, pretty early adopters when we started doing this stuff. So we were like requesting features and submitting bug requests. If you're looking to write a CLI tool, this is where you should start. This would be the first dependency you pull in. It's great. You get help out of the box. You get customizable templates for the help. So let's see if this, let me show you some stuff here. All right. So if I do exorcism -- help, I can't spell. So I get all kinds of great help. That comes right out of the box. We didn't have to write a line of code to get that to work, which is really nice when you're wanting to provide help for people. If you're not documenting your command line interfaces, I might incent you to start doing that. If I want, there we go. If I want help on a certain command, I get that as well. These templates are customizable. These are out of the box. I built this in a weekend, so it's not the greatest under the sun, but super easy to work with. Super easy to work with. So that was good. Actually, let's do this too. Let's look at some code. I'm going to show you some code, so give me a second here. And I'll mirror them. Okay, now I'm looking at what you're looking at, and that's much better for me. Okay. So if we come in here, here's the main function for exorcism. You'll notice on line 14 here, we new up a new CLI app. We give it a name, we give it a usage, some versions, some flags, and then a slice of commands. And he says each one of these is my commands that my command line tool will do. I have a name, a short name, usage, and then here's the action. The action is where all the money happens. This one's kind of long because I didn't take a lot of time to move stuff around. Super nice, super declarative. You can look at the file. You can see, oh, here are the 12 things my command line does. Here's the help for it. My users can start typing help. It's a really nice library. So again, thank you for that. It worked out really well for us. The code's kind of ugly. It's been a little while since I've written Go. So that was where I cut my teeth. I would incent you, if you're going to build a command line tool, build something small and just try it out. Just kick the tires, take a couple hours, go do it. It's fun. So then I started into the Cloud Foundry CLI. I don't know how many commands we had when I started. This was probably 8, 9 months ago when we started this effort. I think there were like 10 or 15, 20 commands. I forget. It's big. What is there? When I took this picture, there's almost 1,800 commits. It's gotten big. So some of the patterns we're using, I'm going to go through some of the code to show you some of the patterns that we're using. Your mileage is going to vary on this. Those of you that get allergies, when you look at design patterns, you might want to close your eyes. The Ruby community design patterns, it causes some pretty nasty reactions in people. Just know that all of these patterns came from refactorings. So we started building. We spiked on it for like 2 weeks to see if this was a viable thing for us to do before we rebuilt it. And it worked out really, really awesomely. So let me just go back so I can see my notes. All right. Okay. So the first thing we did is testing. Pivotal Labs tests everything. Thank you for the built-in testing framework. It was good enough for a long, long time. So the testing built into Go, we loved it. We got a lot of mileage out of it. One of our pivots decided to write his own testing framework. Anybody use RSpec? If you're writing Go, this is the library you might want to look at. He wrote kind of a BDD testing framework. I don't know. I was pretty happy with the built-in stuff, but the team started to go towards this. I've heard rumors that they were actually rewriting the test suite using some of the AST transformations in Go. I've not seen any of that code, but I thought that was really interesting. Like, wow, I have this test suite over here in one dialect. I have this tool to allow me to translate as many as I can into another dialect. That was super cool. Try doing that in Ruby or JavaScript. You would have been rewriting them by hand. So that was pretty cool. So let's look at some code. Let's go back here. If you can't see it, let me know. All right, so let's start in cf.go. So the first thing that was really interesting for us is we were interacting with a command line. So we have this thing called a terminal UI. We decided early on we were going to abstract this into an interface so we could inject it. And we could actually test how our interactions with the terminal went. That was pretty cool. So here's the interface. We have this ask for password method. So we have a method that when you log into Cloud Foundry, I ask you for your password. Obviously, showing you your password on the screen is probably not such a great idea. Anybody tried to hide that stuff in Windows? I did. I copied a bunch of code from the internet. The cool thing about Go, though, is that I can create different files that we compiled for different architectures. So that ask for password method is now Windows specific and Unix specific. And depending on where I'm compiling to, I can compile a different function into my interface. That was super cool. This is the Unix one. For those of you that want to see, there's a big comment at the top that says, hey, this is where I copied this code from. So that was really cool for us. We're like, okay, sweet. Now we can support multiple operating systems with operating specific stuff. That was pretty interesting to us. So if we go into app.go, this command library has been growing and growing and growing. So the team has made a decision to pass in a bunch of metadata about the commands. And we generate these commands on the fly. So as I get metadata and as the commands grow, I can inject the metadata and have the app just generate its own list of commands. So it's really nice. Here, you'll notice I'm just newing up a CLI command. And then in the action, the team's built this runner, so I can run a command based on a name. So when you type in a command in the CLI, it goes and finds that command using a finder and runs it. The commands are all interfaces, which is super nice. So now we can take these commands and unit test them. We just pull them out, and we know they're injected, which is kind of interesting. So the run method is kind of the money here. We have requirements, so that we've been experimenting with what happens if I have to have things happen before my commands run. So we've been using these requirements of like, hey, these things have to happen, and they all have to be successful before this thing can happen. So that's kind of interesting. This is all open source as well, so if you want to check out the gory details of all of this, I can try to lead you through some of it if you'd like. These commands are all dependency injected. So here's a command by name. I create a new create space command. Oh, that's going to be a huge bummer. Oh, there we go. Okay, cool. So we have these things called repositories. So we're interacting with an API at this point. Cloud Foundry has a thing called the Cloud Controller, which is a REST API that I'm hitting when I want to issue commands on the Cloud Controller. So now we've got these repositories, which are interfaces, which can be injected. It worked out really nicely. So we could unit test all the pieces. And then because Go is statically typed, the compiler is linking it all together for us. We did need a ton of integration testing, which anybody that's written Ruby and it has like a capybara suite from hell, yeah, you guys are all laughing. You know what I'm talking about. We didn't need a whole ton of that. We could write these little pieces that we knew were tied together, which was really awesome. In Ruby, and I'm guessing in JavaScript, you just don't get that. So that was the factory. Here's the create space command. So it has a run method. It's injected the CLI context. So I now know what the CLI is telling me, flags, this, that, and the other thing. All the args. I come down here. I have my org repo. I can find an organization by name. I go through all the, the machinations of interactions with the cloud controller for this to happen. And then the one thing we did do, I think I have another bookmark here. Here we go. Is we created structs for the return values. So again, these little data structures that represented the data we were passing around worked out really nicely. So I come in here. Here's the spaces repository. Again, surprise, surprise, it's an interface. I can find that thing by name. It returns me back a space. I have a cloud controller space repository, and then I also have a test repository. So I'm not mocking out my HTTP layer at this point. I just have this repository that acts like a repository. And then here's the space. So super simple structs passing around data, no big organized objects or anything like that. So that's all I have. I wanted to keep it short because I wanted to give us some time for answering questions. You all seem to be fading too. I know I'm fading usually at this point in the day. Does anybody have any questions for me? Thank you. While you're doing that, I'm going to see if I've hit 1,000. Yes! Mission accomplished.
Hey there. Great talk, by the way.
Thank you.
So the question for you is that CLI that you just showed us,
yes.
Is that compiled down to one application, or is that multiple applications?
It's one binary.
And had you kind of talked about the differences and the pros and cons of doing one way versus the other, or did you know right from the get-go you were going to do it that way?
So it's one binary for each platform we deploy to.
Gotcha.
So it's 3. We knew it was going to be 1. So the thing, I don't know if they've fixed this problem yet, but the Ruby CLI had the ability to inject libraries to get more commands. Right now, we have a static list of commands, I believe. So there's been this talk of how do we create a plugin system. And I know Mitchell from HashiCorp has solved this problem. So we're trying to figure out, hey, do we want one CLI tool for everybody of Cloud Foundry, or do we want to give like Cloud Foundry managers one and developers one so that the command set is lower? I'm not sure if the team has solved that yet. So that's kind of where we're at. Did that answer the question?
It did.
Thanks. Okay, cool. Anything else?
Hey, Mike.
Oh, hey, Dr. Nick. He's a contributor.
So as someone who's forked the project, and sorry for not asking the pub last night, but I'll ask now while everyone's listening. You just reminded me, but can you sort of say, why did you create the repository pattern instead of using the HTTP test stubbing?
That's a good question. So anybody that's written HTTP in Go, you know how easy it is to spin up a test server, which is another great thing about Go. The guy I was working with at the time had just come off a Java project where they'd use the repository pattern. I think it works out well because we have multiple ways of interacting with the back end. So without using the repository pattern, we now are tied to kind of HTTP and looking like one thing. If at some point we needed like the cloud controller changed or we wanted to slide in something else, we also use repositories for our configuration files. So now you can save the config to disk and it looks a different way. It was kind of one of those things where like, hey, this is kind of, let's use this. Let's create that extra layer of indirection, which may be one too many, and go that route. I know when Dr. Nick submitted his patch, it's not super easy. It wasn't super easy at the time to contribute because we had all these different layers and it took a little time. It was one of those things where like, hey, let's do this. It looked okay. It wasn't this huge friction. And we're just like, all right, we're just going to keep doing this. And nobody told us, hey, this feels really weird. You shouldn't do it. So, yeah, jury's still out on that. I haven't worked in this code base in a while, so there may be other decisions around this. Reach out to the team. There's a mailing list for it if you want, and find out if I've been pinging them back and forth getting information, but I don't have the latest and greatest information on the tool, unfortunately. Anybody else? I'll be around for the rest of the day as well. I will not be here tomorrow, unfortunately. So if you've got questions, please hit me up today, or you can reach out to me on Twitter, and we can try and figure something out.